All right, let's go on to pumps and piping 2. And in pumps and piping 1, we learned what a pump curve looked like and what a head loss curve looked like. Now we're going to see how do we add curves. So in other words, if we have a pump curve, and it looks like this, and this is head and flow rate, and this is for a pump. What happens if we want to have 2 pumps in parallel? Well, the important thing to note here is that pumps in parallel are very similar to voltage sources in parallel. Whatever the difference in pressure is across this pump will have the same difference in pressure. Just like if we had 2 batteries, they would have the same voltage across them. So for a given pump head, for example, if this, let's give these pumps some names. Let's call this pump A and call this pump B. If this was the pump curve for A or B, if we wanted to double the number of pumps by having 2 of them for a given difference in pressure, we would double the flow rate. So whatever this flow rate is, we would double it. Whatever this flow rate is, we would double it. And so basically what we're doing is taking any point on the curve and moving it horizontally like that. And then the pump curve for A parallel to B would have the same for any given head. It would have double the flow rate. For any given head, we double the flow rate. So adding pumps in parallel, you add them horizontally. And that'll be true for valves as well. In fact, what if we had 2 valves that were identical? And we wanted to have them in parallel. Well, the head loss across this valve, and that's head loss is a difference in pressure, remember, would be the same as the head loss across this valve, the difference in pressure across that valve, yet the flow rate would double. So just like we took any point here and said, well, this is the flow rate, now we double it. This is the flow rate, now we double it. This is the flow rate, maybe that's 1 1/4 inches, now we go out another 1 1/4 inches. And this is 2 inches, now we go out another 2 inches. And so this is graphical addition. So if this is the head loss curve for A or B, this would be the head loss curve for A parallel to B. We can do this again with adding pump curves or head loss curves in series. So if I take a pump and I put it in series, whatever increase in pressure I get here, I get another increase in pressure there, and whatever flow rate came through the first pump, well, that's the same flow rate that is going through the next pump. So if we have a pump curve for A or B, it's the flow rate that gets held constant and the difference in pressure that adds. So you take this height and add it up there. Take this height and add it up there. Take this little height and add it there. And so the pump curve, kind of missed my points there, make them bigger. The pump curve adds vertically. Boy, I'm not happy with my graphical addition there. I'll try it again. There we go. Now I'm happier with my graphical addition. Ignore those blue curves. All right, if I have two valves in series, oh, this would be the pump curve for A, and the way I write series is with an and then the parallel on the previous page. I used the parallel symbol from geometry. So this is the pump curve for A or B, the pump curve for A and B, where they are in series. And if I take two head loss curves, and these are identical curves, the flow rate gets held constant and the head loss adds. So whatever the head loss is across this, I would have another head loss across that. So from the beginning to the end, I would have twice as much head loss for a given flow rate. For a given flow rate, twice as much head loss. For a given flow rate, twice as much head loss. For a given flow rate, twice as much head loss. If this is the head loss for A or B, this would be the head loss for A in series with B. So there we've looked at how do we graphically add pump curves in parallel, pump curves in series, head loss curves in parallel, head loss in series. Maybe just put some words down here. Let's see here. There we go. Series, add vertically, parallel, add horizontally. There we go.